Okay, so let's look at some of these boundaries where they are on the Earth. We're going to start with divergent boundary. A great example of a divergent boundary is here in the mid-Atlantic ridge, right? And you can see the pattern on the ocean floor of where it is ripping apart. Again, this is going this way, this is going that way, and you can see the rift valley that forms in between, which is really, really, really cool, right? This, of course, would be the youngest rock. This would be older, this would be older. So on your stripe going across by divergent, you're gonna explain both plates are pulling apart. The geologic formation you'd find there is a mid-ocean ridge. An example of where to find it is the mid-Atlantic ridge, that's one. The other place you can find it that's a really good example is the Red Sea. Look at that, you can see it right there. That is the mid-ocean ridge found in the Red Sea, where Saudi Arabia is going that way and Africa is going that way, right? Pretty cool. Another boundary we can find is a transform boundary. Probably the most famous place to find the transform boundary is going to be in California at the San Andreas. And when you go to look at the San Andreas, there's really nothing to see. Even if I search San Andreas, right, there's just, I mean, there's not, if you're actually down there, this is all you don't see anything. It's there somewhere, but there's not anything you can really detect. So for the formation, you say nothing. And for the first part, what's happening with the two plates? They're just sliding side by side. And again, as the best example would be San Andreas Fault in California. I see many of you updating your types of boundary sheet. That would make a lot of sense to me. And then finally, we get into our convergent boundaries, but there's several different kinds of convergent boundaries. Let's start with the most simple and look at a continental convergent boundary. The best example of that would be where India has smashed its way into Asia. And can you see this line? It's white. Why is it white? Because those are all the mountains that are being folded up by this continental intercontinental boundary, right? So there's Kathmandu, which means Mount Everest has to be nearby. There it is. So there's Mount Everest right there, right? And if we go 3D on it, you can see it pretty well. Which is pretty awesome. I think there's some pictures of Everest. Yeah, check this out. Wow. Totally cool. There they are at base camp. So fun. Right? It is a wild, wild, wild place. Right? Mount Everest. Totally cool. Right? One of the highest places on Earth because, again, you have two different continental plates slamming into one another. You can also tell it's going to be just regular mountains because, look, there's no water anywhere. There's no ocean. You need an ocean making a volcano to have volcanic mountains. We don't see any. Right? So that is continental convergent. What's happening? Two plates are crashing into one another. Neither one of them is dense enough to subduct, so they both go up. Right? Those listening, that's not for you. Okay, so now we look at maybe a continental oceanic boundary. A great example of that would happen here, where you have the oceanic plate crashing into Japan, and you'll get Mount Fuji, which is a pretty spectacular place. There's a great picture of like a video of Mount Fuji, it looks like. This is a surprise to me, kids. Let's see. Who's going to Mount Fuji? He is. Okay, I don't care. But there's probably some really cool pictures. There's a good picture of Mount Fuji. All right, look how pretty, right? So huge in the background. Mount Fuji's pretty incredible. Right? It is a cinder cone volcano, which means it's just very symmetrical on all sides. It's pretty darn cool. And how do we know it's a volcano? Well, that one looks pretty obvious to me, but also there should be an ocean nearby. Yep, there it is. So it's kind of a giveaway that it is volcanic, where this plate is going under this continent, this continental plate, and therefore where that oceanic plate is melted, it's going to cause a volcano above it. Probably a better example, or at least one closer to home, is going to be on the other side of the Ring of Fire, which you can kind of see here. And that's with this little plate. It's called the Juan de Fuca plate. And the Juan de Fuca plate is being pushed under this part of the United States. And you can see all these volcanic mountains that pop up. Mount Rainier is a cool one, but even cooler is this guy, Mount St. Helens. You can see where this whole side blew out, right? Because it went that way for the most part. And you can see how damaging, how wild this is, right? Again, some cool pictures, hopefully. Do they have any? Yeah. Here's some really cool ones, right? Look at that. You can see where it blew out this whole side there, right? Totally cool. A third example of an oceanic continental convergent boundary would be, again, following the Ring of Fire, this whole part of South America, this whole side is one gigantic volcano range where this oceanic plate, you can see where it goes underneath the continental plate, and this is all volcanoes. These are called the Andes Mountains, and all the Andes Mountains are volcanic. And it also defines the countries that are here, right? Which is totally cool. So these are all volcanic mountains in the background. Totally cool. And the range goes the whole way down South America's west side, making that part of the Ring of Fire, which is really cool. Again, this boundary, what's happening? An oceanic and continental plate are coming together. The oceanic plate is the one that subducts, and it creates a volcano. The last one we have is an oceanic convergent boundary. And again, we follow the Ring of Fire and we find this guy. It looks like an upside down question mark. There's Japan, there's Taiwan, there's the Philippines, and this, my friends, is called the Marianas Trench. Two ocean plates are coming together. Both of them actually want to subduct. Only the oldest one eventually does, but this is where you'll get a trench formation, right? The deepest part of this is called the Challenger Deep. It's the deepest natural spot on our Earth's crust. So again, this is what you need to know about each of the boundaries. You've got to tell me what's going on with the plate. You've got to tell me what kind of geologic formation I'm going to find, and you've got to name a specific place in the world where I could go see it. That's 3 things. There's 5 boundaries. That's why I call it the Big 15. Fair enough? All right. Good luck.